And this is another example of what I wanted to show you as the interaction between the CPU and the memory. So you will find there are things like the instruction register. You have to break it down. Assume that you have got a dumb servant. So every instruction has to be broken down to a very, very simple level. And these simple instruction register, these instructions are brought into the registers and then processed through the CPU. So you will find that there is an instruction register, there is a program counter. What will be the next instruction is put in the queue, and as soon as this instruction is processed, the next one comes in actually. And then we have got the registers, variety of registers. These are, as I said, temporary file folders where you take the data, process it, and put it back onto the output registers. So you will find there is a memory data register, there is a memory address register. Now data is stored in, assume that you have got a locker bank actually. Now the lockers have got on the top of it the addresses. What you put inside the locker is something different, that is the data. But so if I say 32 locker, what is inside 32 locker? I don't know. But in 32 locker, so if I say that address is a very important part, I go to that address, open up the register and see what is the data available. So most of the instructions will be that go to 32, okay? Then collect the data and use it for the purpose of addition or subtraction or whatever instructions are there. Then the output will be put into another locker. So that address of that locker is more important, not the content of the locker. The content of the locker will be fetched as soon as I go to that address and fetch it. Now these are some of the steps that are executed by the processing unit, and for which it requires the memory, and the internal structure will have these things like the memory address register, memory data register. There is a program counter. Every time the instructions are to be executed, so large number of these instructions will have the ID numbers, and it goes on executing these instructions. So this is essentially the kind of internal design or the architecture of the memory and the CPU. And that generally will give you, if you are more interested, generally you will find there are courses on computer architecture. And the computer architecture course will go into all the details of what I have just told you in about 15-20 minutes. But just to give you an idea that when you execute a program, a lot of things happen inside that machine. And it's fascinating to see the details of it actually. Now let's say that we have got a program. And the program is written in a language which is amenable to you or which is decipherable, or you can write it in your own way. Earlier I remember there used to be a language called COBOL, and COBOL was almost like a machine level language. We have to write down the program in almost a machine level form. But today it is not the case. Whether it is Fortran, whether it is Pascal, whether it is C, whether it is C++, whether it is Java, whether it is Python, all these languages are called as high-level programming languages. When you write a program in that high-level language, the program instruction set is called as the source code. Okay. Now this source code is then first looked into in the sense that have you done the syntactical things properly, have you got all the rules and regulations properly, and that is checked whether the program is logically and syntactically correct. That is generally checked, and then it is put, this whole program becomes the data of another program. Now this program is called as compiler. The compiler takes your program as the input data and puts out another program which is in the form of object code. So source code gets converted into object code, and the purpose of compiler is to convert the source code into object code. The object code is readable by the machine. Okay. Now these object code, once it is there, you have reached half of your battle. That at least you have written the program correctly, and therefore it is able to convert it into an object code. Then the next thing that happens is now this object code is loaded into the central processing unit, and it starts executing the instructions. Now if you say A plus B is equal to C, so it will say where is A stored, give me the data available in A. Where is the B stored, give me the data available in B. Add it up and put it in a address where the C has to be put in actually. Now this whole work has to be done, which is the execution part of it. So compilation is different, execution is different. You may write a program which gets compiled, which means the object code is generated. Then it gets executed, which is where the next part happens. Now this whole thing is done in a computer, and the computer has its own monitoring or some sort of a law and order or program, which is usually called as the operating system. So when you use a computer, you will find there is one program. When you switch on, you will find that it goes through a lot of steps actually. Those steps are executed through the operating system. So every computer you will find has an operating system, and this operating system could be, I will show you some of the things. Compilers, there are a variety of compilers that are there, and there is another whole approach which is of programming, which is a different approach, which is called as interpreters. So in the software world, you will find there are interpreters, there are programmers, there are compilers, there are operating systems, and then you have got a source code. As far as you are concerned, you don't have to worry about the rest of the things. You have to write your own program and get it executed. So long as you feed the program and you get the answers, you should be happy about it. But these are some of the programs which are working behind the scene for you. And this is the world which you are going to deal with now for the rest of the semester in this program, particularly related to the Python language. So as I just now mentioned, the syntactical code, the syntactical errors, then the language errors, then compilation to generate the object code, execute the object code, translate. Now the interpreters is a very different thing. Interpreter is like, I type a line or I feed in a line. The moment I hit the return, that means this line which I have typed gets submitted and it gets executed. So this will be like if I put in say for instance one line plus 3, 4 and return. So it will give me either I have done the instruction properly or I have not done the instruction properly. If I have done the instruction properly, it will just come out with 7 and output is available to you. If you have done something wrong, it will come up with an error. So if line by line processing takes place right at that instant without going through this compilation business, what happens inside is a different thing, but this mechanism or this interaction is called as interpreter. And Python is an interpretive language. There is another language called Lisp. Lisp stands for List Processing Language, and Lisp was another language. You may call it as a precursor to Python. Python is much, much better than Lisp actually. So Python, Lisp are interpretive languages. They are not the languages which are like the C or Pascal, etc., where you need to do the compilation of the program and then the execution of the program. Here the compilation execution happens line by line actually. And this is something a beauty, and therefore for a student the interpretive languages are far better than the usual compilation languages actually. And therefore you will find that we are using Python in this particular course. So Lisp and Python are the interpretive languages. Fortran 77, I remember the good old days, everything was done in Fortran, and the version, Fortran by the way stands for Formula Translation. So the Fortran is a concocted word of formula translation. 77 was the year in which that compiler came up, and therefore it is called as Fortran 77. There are various versions of Fortran. Pascal, C, and there is an object-oriented language called Java, and of course Python is also an object-oriented language. So there is a concept of structural language or object-oriented language that you will come to know when you start learning the details of the Python language. Now when you execute the program, you will find that there is something called the runtime error. Okay. When let's say you have created the object code and still you don't get the right results, okay, or you get results. As I told you last time, a simple example of a runtime error is the division by 0. So you have got the program well written, but then you have forgotten and you gave the data wherein the denominator was 0. So obviously the error will not be detected at the compilation level, the error will be detected at the execution level, and that is usually called as the runtime error. And these so when you run the program, first you have to make sure that it is well written, so compilation is successful. The second part is you have got a runtime error, you have to analyze them. Now these two paradigms that I mentioned to you, first one is the compilation execution paradigm, second one is the interpretation or interpretive paradigm. The third paradigm is what we call as the menu driven programs. You used AutoCAD last semester, I'm sure all of you. Now AutoCAD is also a program, by the way, and that program is not running in the fashion that we are doing. Whatever you did, whether you want to draw a circle, whether you want to draw a line, you will find there was always a command prompt, as if you have got a servant who is what I call it as, you know, the difference between a menu driven program and the other program is that if you want to go to a restaurant, you will find you get a menu card. So you say whether you want idli, dosa, vada, sambar, etc., etc. Now you don't ask idli mein dal hai ya chawal kitna hai, I mean, sort of, you know. So you will find the recipe of making idli is none of your business. You just tell that I want idli or I want vada or something like that. So that's a menu driven program. But if you want to go and cook idlis at home, you have to take a book of recipes, or you have to talk to your elderly person in the family who will then give you the instructions, and then you have to make the idli from the raw data, whether it is the dal or rice or whatever. But that is like your Fortran program or a Pascal program, and AutoCAD is like your restaurant idli, I mean, sort of, you know. So there you will find that there is a menu card type of a thing, and somebody is waiting for you all the time. Because if you open the AutoCAD and if you do nothing, nothing will happen. So unless you put the command there, line or circle or triangle or whatever, so you will find that you are using that as a menu driven program. The menu driven program is a very different paradigm compared to the interpretive language that I mentioned, or for that matter, the other language that I said, compile execute type of language actually. So in this case what happens is commands get executed. The program is all the time in the wait mode at the back of it. The AutoCAD is always in the wait mode till you complete and you open up a file, and whatever is your interaction you store it in that file. That's also possible. Data is put in a file, and menu driven data, whatever is the data that you are putting in, that gets compiled, or .dwg. I'm sure all of you are familiar with that extension name, that whatever is you are drawing is a file. That file is having a very specific extension of .dwg file actually. So that's a different third paradigm. So you have got menu driven programs, you have got the interpretive type of programs, or you have got compile execution program. In our course we are going to go more in the detail of the Python language, because that is very easy to learn. You will find it right from the next to next lecture, you will start learning the Python language and the details of it actually. So computer system software, as I told you, the operating system is the DOS, as well as the Windows and the Unix operating system. The coordination of the function is carried through the operating system. So DOS was the disk operating system, which was developed by the Bill Gates. Unix is a very popular open source software. Of course there are now commercial versions of Unix also, and the Windows is another. So all the three are very landmark developments. First one was a disk operating system. Second one was the Unix. Unix allowed you to do multitasking and many other things. And now you will find that you have got multiple windows. You open up the windows, you put the processes, and all these things are happening at the back. And that is also a kind of an operating system which allow you to do multiple windows and multiple processes. The coordination is the job of the operating system. I want to give you a little bit of a glimpse of some of the other things that have happened. Graphics is very fascinating, and a lot of things have happened in the graphical world. Earlier we used to do only alphabets. Graphics was not possible, but today you saw yourself how powerful the things are, and AutoCAD is the simplest of the software. In fact, you will find when you see the Jurassic Park, or when you see some of these Avatar films, etc., 50% of that film is on computer graphics actually. So you will find, whether it is the recent film called Life of Pi, a huge amount of work was through computer graphics effects. So a very important branch of computer science is related to animation and computer graphics. I will just go, or maybe what I can do is to stop at this point and pick up in the next class from here onwards actually, So I will put the slides well in advance today itself so that you can have a look at it. Our next class will be on Tuesday. Okay, and then I will wrap the whole thing at that time. Thank you very much. Make sure that you have recorded your attendance.